Welcome to the deep dive. So today we're tearing into the specs for a piece of environmental monitoring hardware, and this goes far beyond a standard consumer device. We're talking about the NTI E-GD-MBP gas detector.
Exactly. This is all about mission-critical accuracy for, serious industrial environments.
And NTI, that's Network Technologies, Inc., they design for that kind of high-stakes system integration.
That's the key. So our goal for you is to really analyze this feature list and understand the why behind their engineering choices.
Okay, so what gases are we talking about here?
It's continuously monitoring the air for the standard combustible leaks. So methane, propane, butane, and acetylene. It's always on.
Okay, let's unpack this then. The sources mention this device operates on two separate selectable warning thresholds. Why do that? Why not just use a single hard-cut alarm point for safety?
And that leads us to a really critical distinction. It's about preventative maintenance versus just an emergency response.
Okay.
When you look at the specs, you see the first level of detection is set, well, intentionally very low.
How low are we talking?
It detects methane above just 0.5% concentration, and for propane or isobutane, it's above 0.3%.
And the second, more severe level.
That one triggers when methane concentration goes over 0.8% and propane or isobutane exceeds 0.5%.
Right, so what does that actually mean in the real world?
Well, we connect this to the bigger picture. These levels are just fractions of the lower explosive limit, the LEL.
The point where it can actually ignite.
Exactly. The LEL for methane is about 5% concentration. So by having that level 1 alarm way down at 0.5%, you're getting a pre-alert. It allows a facility manager to check for a small leak long before the environment becomes genuinely dangerous.
I see. So it's about managing a threat, not just reacting to a catastrophe.
It's designed for preventative intervention. That's the whole idea.
That makes a lot of sense. But precision is pretty useless if the system can't act on that data. How is this detector actually built to communicate a threat to the rest of the facility?
First off, the physical alert is, well, it's impossible to ignore. It blasts out an audible alarm signal rated at 94 dB. At 1 foot.
94! That's extremely loud.
It has to be. I mean, think about where you'd install this. A server room with cooling fans blasting, or a noisy industrial facility. A lower decibel alarm would just get lost.
Okay, so beyond just making a lot of noise, the capacity for large-scale integration seems to be the real value here. I'm looking at these heavy-duty technical relay specs. Level selectable can be normally open or normally closed.
And that choice between normally open or closed offers maximum flexibility for the installer. It means it can either close a circuit when an alarm goes off or open one.
It also handles up to 250 VAC with a max of 5 amps.
And that 5 amp rating,
Mm-hmm.
that's the crucial insight for you if you're a system designer.
Why is that so important?
Because it means the detector can directly control higher power components. Things like a big ventilation fan or a solenoid valve to shut off a gas line, or even a heavy-duty strobe light. You don't need an intermediate relay board. That simplifies the install and, reduces the total cost of ownership for a large system.
We've seen the impressive integration specs, but let's talk about the price. It's listed at $395 retail. That feels like a very commercial price point for combustible gas detection. Is it the reach of the architecture that justifies that cost?
Absolutely. The extensive power and data transmission capabilities, they really confirm its role in large centralized systems.
It's designed to be powered remotely, right?
Yes, and it can handle a maximum cable length of 1,000 feet. That's over 300 meters.
Wow.
Think about what that means. This single unit can cover, say, 2 large data center floors or a significant warehouse perimeter, all without needing local power or repeater stations. That's a massive architectural advantage.
So when you put it all together, what does this all mean? The NTI EGD-MBP is a highly integrated dual-threshold detector built specifically for industrial compliance and centralized monitoring.
And validated by its CE approval and its TAA compliance, which is important. That means it qualifies for U.S. government contracts.
All for $395, and it includes a 2-year warranty.
Right. And this raises a really important question for you to consider. When you compare the price of this specific combustible gas detector at $395 to other related NTI products, like their carbon monoxide detector, which is $290,
Wow.
or the hydrogen sulfide detector, which is $12,210.
That's a huge difference.
It is. So the question is, what complex factors? Is it the sensor material scarcity, the regulatory burden of the specific gas, or maybe just the manufacturing complexity? What is it that fundamentally drives that huge variance in cost, all to achieve that same mission-critical accuracy?